Good morning everyone. Welcome back to my channel Ace to Excel. Today we'll be talking about counters. Counters are applications of flip-flops. Counters, they are type of sequential circuits which are used to count number of sequences in an event. For making counters, flip-flops are the basic components used for it. Counters can be made using JK or they can also be made using T flip-flops. There are two types of counters and they are broadly classified as synchronous counter and asynchronous counter. Asynchronous counter's other name is ripple counter. Do keep in mind, asynchronous counters are normally asked with the term as ripple counter. Counters can also be classified into two types, up counter and down counter. To bring out the difference between all of them, first talk about up counter. As the name suggests, up counter means that the counter is in increasing order. When I say increasing order, it is 0, 1, 2, 3. Do keep in mind, we are talking in binary, and in binary we always start with number 0 and we never start with number 1. Similarly, down counter is that counter where counter is in decreasing order. When I say decreasing order, it will be n minus 1, let us say 3, 2, 1 and 0. Then coming to the broader classifications of counters, in which we classify counters as asynchronous counter. The term asynchronous counter means that the counters are not having same clock pulse. That is, this type of counter is made that every flip-flop's output is triggered by the previous flip-flop's output. Definitely, in such a circuit, time of operation increases because one circuit triggers the other. I again repeat, asynchronous counters are known as ripple counter. Another term which is associated with the counters is known as mod. Mod, also known as modulus, is defined as number of states a counter counts. If I say I am going to design a 2-bit counter, a 2-bit asynchronous up counter, that means this counter is also known as mod 4 counter. Mod 4 means it will count 4 number of stages. Let's start the designing part. Now we are working on which type of counter? We are working on asynchronous type of counter where clock plays a significant role. So do keep in mind, whenever the question is about asynchronous counter, the crystal clear condition is that clock can be positive clock can be negative clock. When I say positive clock means rising edge clock. Negative clock means falling edge clock. Let's first talk about the two types of clock pulses. When I say rise edge clock or positive edge triggered clock, in that type of clock, the circuit will change its state at the places where an arrow is marked. That is during the up counting. While when it is fall edge or negative edge, it will always change the state whenever it is going down, that is, it is in the fall stage. Now, we'll be designing the clock, and for designing asynchronous counter, this basic map should be kept in mind that there are two types of clock, positive clock, negative clock. There are two types of flip-flop outputs in every flip-flop, positive output and negative output, that is Qn and Qn bar. If positive combines with positive, designing of counter will be down. While if positive aligns with negative, type of counter which will be made is up. Similarly, if negative combines with positive output, it is up counting. While if negative combines with Q bar, it will be down counter, and this is the basic foundation of counters. Now let's start quickly designing the counters. As we said, we'll be talking about 2-bit asynchronous up counter. Up counter can be made in two ways. One is with positive clock, and with positive clock we need to take Q bar as the output, while if it is a negative clock we need to consider Q as the output, which will be triggering the next flip-flop. Now let's start designing. 2-bit counter means how many number of flip-flops? Do keep in mind, number of flip-flops will always be equivalent to bits. So 2 bits means number of flip-flops required are 2. Number of states and every counter can count is always equal to 2 raised to power n, where n is number of bits. So if it is 2 bits, the number of states will be 4. Again, 4 means mod 4 counter we are going to design. Now, if I say mod 4, definitely binary is in two terms, 0 and 1. 4 possible combinations are 0, 0, 0, 1, 1, 0, 1, 1. So total number of states it will count is 4, which is known as modulus. Modulus of 2-bit counter is mod 4 counter. If the counter is up, it will count 0, 1, 2. If the counter is down, it will count 3, 2, 1, 0 and so on. Now, in designing, we'll be considering that 2 flip-flops which are used are of T-type. We will be using T-type flip-flop. T-type flip-flop always toggles when it is given high value, that is T is equal to 1. Second thing which you will keep in mind is number of states should be 4, and because it is up counter, so the counting should be in increasing order. Now we are going to design the type of counter as asynchronous. Asynchronous means output of first flip-flop will act as clock to the second flip-flop. We have opted for negative clock pulse, so negative clock pulse always come with a bubble sign. We'll be using T, and T toggles when T is equal to 1. So number of circuits in the system will be 2 flip-flops. Type of flip-flop is T. T has only one input, so we have attached it to 2T, and the value of T is high. High means T is equal to 1. Now, always keep in mind another fundamental concept, that outermost flip-flop is the MSB and innermost flip-flop is the LSB. Right. Now, we are using negative clock, so Q will act as the clock pulse for upcoming flip-flop circuit. Now, we'll quickly design the timing diagram, because timing diagram is the basic thing which a up counter needs or a asynchronous counter needs. For the timing diagram, we need clock pulses. So I'll be quickly drawing the clock pulses in front of you. And because it is a negative edge triggered clock, so I'll be marking the negative edge of this clock pulse. The negative edge means every flip-flop will change its state when the negative pulse comes. Now, we have two inputs, 2 flip-flops in the circuits. First one is QA, second one is QB. Do keep in mind, as the circuit shows, QA is LSB, QB is MSB, and LSB always changes its state. Putting a dotted diagram at the negative edge triggered clock so that you can understand that how the state changes. Now, first QA changes its state. When QA changes its state, the timing diagram of QA is as shown. The system will change the state at every negative edge. Now, this QA's output is clocked to QB. So we need to mark the negative edge of QA so that we can come to know where is the negative edge of QA. At these highlighted points, QB will change its state. Let us see how QB works. This is the timing pulse of QB. If you observe, the value is 00, 01, 10, 11 and again it is 0 0. So counting comes as 0 0, 0 1, 1 0, 1 1, and do note QA is LSB, QB is MSB, and counting is done in this sequence, and this is how we have made mod 4 asynchronous up counter. Mod 4 means it is 2-bit asynchronous up counter. To be highlighted, asynchronous means first flip-flop's output is acting as a clock to the second flip-flop, that is the upcoming.